7.9 was actually 2 earthquakes, one here, and then about 60 seconds later, another one over here. All right? Even when you add those two together, they end up being so much less slip than what happened in 1833 or in 1797 that we are concerned that, in fact, this covered so little of the area that actually we know to be locked, okay, that we're still concerned about this rupturing. We're still very concerned about this going in the future. The problem is we don't yet know how, I can't yet tell you how often it ruptures and whether or not we're likely to see in the next few months or years or decades another great or giant earthquake here. What's left, though, is most of this area that broke last in 1797. Okay, so 210 years. Once we know how often these ruptures happen, once we know more about the history of these ruptures, we can tell you more about whether things are really imminent or not. Okay. Okay. So I think there are just two of you here right now. So who are with the media. So if you have questions, why don't you go ahead and ask them. If you would like to have some more detail, there's more detail available here, but I thought you might very well not. So Tanya, and I don't believe I know the name of the woman from the other paper.
So what exactly would you need to know to determine the timeline? What kind of data would you need?
Let me be straight with you about this. We have another paper coming out in a week, and I can't talk at all about that until next week. Okay? So I can't even tell you where it's coming out, what paper it's coming out in.
The one talking about when and the time? Okay.
Yeah. Yeah. I can't say anything more about it now or I get in big trouble with the magazine. So, sorry. It's a bit of a teaser, I know, Tanya, but so there's I can show you a little bit more detail here. Here's the 8.4. Here are the GPS vectors for the 8.4, the horizontal motions. Here's how well the model fits. This is now taking apart the 8.4, 7.0, and 7.9, and here's the epicenter of that. And then here are the verticals. The island I showed you is about right here that went up a meter, and you can see it was more in the north, more in the south, and less in the north, and it died off very rapidly. There were no motions at all here. And then here's how well the model fits. Again, the islands went up and the mainland went down. And then here's the model just for the 8.4. You can see there's on the order of 4 or 5 meters of slippage or so. Okay. And then here are the contours: 1 meter of slip, 5 meters of slip, 7 meters of slip. You can see that in this earthquake there were 2 little tiny patches, not so little actually, about 50 kilometers or so in dimension, 2 patches that constitute that earthquake. So this entire section is locked, but only these 2 little patches went in this 8.4. Now in the 7.9, here are the motions. There's motions here, less motion in the middle, and more motion on the end here. So that's why we know that there's a big patch here that broke, or a little patch here and a little patch here. Here are the model fits to the horizontal data. Here are the vertical data, islands up, mainland down. And here are the fits of those data. And there's the epicenter. And then here, in fact, is what happened during that earthquake. So, so we have, whoops, let me go back. So here we have one little patch right here. And what is that? That's about, maybe 40 kilometers in dimension with slip up to 5 or so meters. And a teeny little patch here with just a small amount of slip. Okay? And then the earthquakes that happened earlier this year, after these, the aftershocks, they were in this area. There was one actually a 7 that occurred in a bunch of 6s. So there's all these small and moderate little earthquakes happening after the 8.4, and which is really intriguing.
So, but you're saying that basically even the 8.4 is only a quarter of the magnitude of what could potentially happen. Right. Okay.
So now the question is, will this Mentawai patch be satisfied to only relieve a quarter of its strain? And the obvious answer is probably not. But the question is when. When will it happen?
So what is the magnitude of this large earthquake that you are?
In the past, those 2 earthquakes that occurred 175 and 210 years ago, those we believe from all of our uplifted corals that we've measured over the last 10, 15 years, were on the order of 8.7, 8.8, 9.0. So the 1833 event appears to be about a 9.0. So since the magnitude scale is a logarithmic scale, an 8.4 and a 9.0 are vastly different in size. There's still about 300 kilometers that has not slipped at all on the Mentawai patch. And even the part that did slip in the last event didn't slip as much as it did in 1833 or in 1797.
Would this model be applicable elsewhere?
This model?
Yeah.
Well, that model actually is tailored to fit those geodetic data specifically, and the seismic data, which I didn't talk about. So the same basic techniques are used in Peru and Chile and North America and all over the world. It's just using a scientific field called continuum mechanics. Okay, so there's nothing special about that method. It's just that Sumatra happens to be the most active, most energetic place in the world right now with regard to earthquakes. There's the last time there were 3 magnitude 8 pluses all in one area. You know, we had 9.2 in 2004, 8.7 further south in just north of the equator in 2005, and then now the 8.4. The only other place that's had 3 events like that happen in the entirety of the instrumental record, the last 100 years, let's say, is Alaska, where there were 3 magnitude 8 pluses in a course of about 9 years. So having these three giant earthquakes or great earthquakes all within 4 years or 3 years is actually unparalleled in the historical record. You know, we have no written records or instrumental records of so many 8 pluses happening within such a short period of time. Now we're excited, even if it's just 2 of you guys here, we're really excited because this is the first time we've been able to do a media conference here in our brand new observatory. And so what
else is the observatory doing after this? This is quite a big, breakthrough in that sense for the region. What?
Yeah.
I mean, and
we're going to do this. We're going to do this better. Actually, is what we're going to do. We've been operating from the United States until I moved here, and so we set this network to let's see, is this one I want? I guess I'll leave it here. No, I'll leave it there. There. We set up this network of 30-some stations, and the observatory will be actually assuming the maintenance responsibility for that, and we'll be expanding it. We'll be increasing the number of stations so that we can monitor the unbroken section better. We also want to monitor the area that broke in 2005, which is this patch here. The entirety of this patch seems to have broken in 2005. So we're going to improve our measurements here in Sumatra. It'll be one of our several projects that we have going from the very start. But you may recall we also are going to be doing volcanology in Sumatra, in all of Indonesia, and the Philippines, and so on. And we'll have projects in Myanmar that are going. We're trying to develop new ways of monitoring, new ways of telemetry with our colleagues in computer engineering, and working with earthquake engineers over in civil engineering on issues regarding safety, shaking safety.
So how can this data from this paper be applied? I mean, and what do you intend to do with it?
What it does is it tells us what happened in almost unprecedented detail. What I've just shown you is it's extremely rare that you can actually, well, in fact, this is probably the best understood magnitude 8 plus earthquake anywhere in the world, probably. I'd have to think about that a bit, but it's extremely unusual to have GPS stations sitting right on top of a big earthquake. And in fact, there are only 2 cases I know where that's happened. We had instruments up here on Nias when the earthquake happened in 2005, but we only had 2, one here and one here. So we learned the details of that earthquake better than had ever been done before for an 8 plus. But then we had many more instruments here, both on the mainland and here. So this is probably one of the best constrained magnitude 8 pluses ever recorded. So what we're going to do with that is we can compare it now with what we know happened in the previous earthquakes, and we can say, oh, look, it's only a quarter of